Hello, everybody, and welcome to We Measure the World, a podcast produced by scientists for scientists.
The ability of a grafted plant to withstand drought is incredible. So, two plants very similar, where the only difference between them is the root system. And to see one of them dying and the other one not even realizing that has been without water for 10 days, I think that's the highlight of this research.
That's just a small taste of what we have in store for you today. We Measure the World explores interesting environmental research trends, how scientists are solving research issues, and what tools are helping them better understand measurements across the entire soil-plant atmosphere continuum. Today's guest is Cecilia Heller. Cecilia earned her bachelor's degree in agronomic engineering from the University of Passo Fundo in Brazil. Cecilia was also a recipient of the 2022 G.A. Harris Fellowship sponsored by Meter here. And she is currently a PhD student in horticultural sciences at the University of Florida, where her focus is on grafted blueberry physiology and production. Her research centers on developing production systems that enhance climate resilience in blueberry crops to address critical global agricultural challenges. And today she's here to talk about grafting as a tool for blueberry resilience. So, Cecilia, thank you so much for being here.
Thank you, Brad. It's really nice to be here. Thank you for having me in your podcast.
Definitely. So we wanted to start off, as we do with all of our guests, and just kind of get a little bit into your background. Could you just share with us a little bit about your background, how you got into horticulture in general, and what inspired you to focus on blueberry horticulture?
So I actually grew up in a farm. My dad is a farmer. He's a soybean farmer. So my entire life, I was surrounded by plants. And I really couldn't see myself doing anything else. I knew I wanted to work with plants. So I started my bachelor's in agronomic engineering. And during my period in school, I knew I wanted to do something. I wanted to study outside of Brazil. So I started to look for an internship while I was doing my bachelor's. And I ended up coming to University of Florida. Being here opened so many doors for me. So the people I met here at the University of Florida really helped me shape my path. I was a little bit lost. I didn't know exactly what I wanted to study. And I ended up working with blueberries. I didn't know blueberries. The first time I ate a blueberry was here. And that's when I really started my blueberry journey. After I spent 1 year working with blueberries at UF, I started grad school, so I started as a master's student. After a year, I switched to the PhD, and now I'm on my third year. I work with grafted blueberries, as you said, so we're trying to develop a better way to grow blueberries using less resources. And I really love my research. I need to say that I really like my research. I think there's a lot of potential.
With your learnings about blueberries, are blueberries not very common there in Brazil? You don't find them, or they're not sold there?
They were not, at least until 5 years ago. That's when I moved here. You could find them on grocery stores, but never really grown in Brazil. But since I left and since I started learning more about blueberries, I know that the production in Brazil is really expanding. So I know that there are more growers in different states. I know that they are doing research. I could visit some research centers when I was visiting Brazil too, which was very, very cool. Leaving Brazil, I did not expect to work with blueberries. And now going back there to see all of these changes is really nice.
Cool. That's interesting. So what have you learned then, say, for instance, about the background of blueberry horticulture? From my understanding, blueberries and its, various cousins, they've evolved to adapt to more cold weather regions. Is that correct? Am I understanding that correctly?
So we do have a blueberry breeding program at the University of Florida. Here, what they are focused on developing is actually the opposite, is cultivars that are better developed to produce with less chill hours. So because Florida is so hot. It's very different from up north where blueberries are generally grown. Here we are trying to have this new cultivars that can produce better in a low chill environment.
This is the same for lots of different crops where there are breeding programs to try to develop, like you said, new cultivars or varieties of various crops to be planted and grow and produce in a wide variety of environments and conditions. So it seems that your blueberry research and research that others are doing kind of fits into that as well. So we're trying to be able to grow blueberries, have them produce more abundantly in both indoor, outdoor settings, warm environments, cooler environments, like you said, with chill hours, chill days, those kinds of things. That kind of seems to be the case, right?
Exactly.
Let's just jump right into your main research then that you're doing when it comes to, I mean, among other things, grafting. We've talked to different plant researchers. I don't think we've talked to anybody who's focused on grafting. So I'd love to just kind of dig into that and see how did that project get started and the idea of grafting when it comes to blueberries in order to improve their production and their resilience.
So grafting is not typically used on blueberries. It is very common on other fruit tree crops, but not in blueberries. It's not something that you see anywhere. But one of my advisors, Dr. Jeffrey Williamson, he started this project, this grafting idea, around 15 years ago. And since then, a slow process to accomplish results and to get data to really see if these plants can do good for the blueberries. So basically what we want to do is we are using sparkleberry as our rootstock. Sparkleberry is a native plant, is a close relative to blueberries. And the difference between the sparkleberry and the blueberry is mainly on the root system. So blueberries, they have a very fine and shallow root system. It doesn't grow very deep into the soil. But sparkleberry has this root system that grows wide and deep into the soil. Even more benefits to using the sparkleberry. And another thing that is really important that we look into is the plant architecture. And that's why blueberries haven't been grafted before. Blueberries are a bushy architecture. They have multiple canes coming from the ground. And that doesn't allow for a good graft. So the sparkleberry can be trained to have a single trunk architecture. So instead of having lots of canes coming out of the ground, we're going to have one single trunk that's going to transform this blueberry bush into a tree. This part, this plant architecture idea, is not really the focus of my project, but it can really help the growers with mechanical harvest. So that's the idea for the single trunk architecture, to be able to harvest these plants easier.
So really quickly, blueberries, from what I've read, there's low bush and high bush. Is that correct? And so the native blueberries are more the low bush. The wilds are the low bush, and the ones that have been cultivated. So the plant varieties that have been cultivated are more of the high bush. So when we're dealing with the grafting, we're dealing with these high bush cultivated varieties. And there's a long way of coming around to asking about the harvest process in general. So we have multiple berries that are coming off of each of the branches of the plant. How does that harvest process work? And then how does the grafting aid in that harvest process?
So the idea of grafting for mechanical harvest is because first, blueberries are generally mainly hand harvested. So it's a huge expense for the growers to have all of those manual labor during season. And machine harvesting, the problem with machine harvesting is the bush, the blueberry plant, has all these canes coming out of the ground. So it is a wide plant in the bottom. And the machine harvester has some clamps in the bottom that have to close this plant and kind of shake to collect all the berries that fall. The difference with the single trunk is that you would be able to close these clamps better together, have less of a space for the blueberries to pass by for you to lose berries. So in theory, you would lose less berries because you can capture all of the ones that are falling from the plant.
So, can you explain, I guess, some of the specific grafting techniques that you're using in your research? I know very little about grafting. Are there different techniques that you use with grafting blueberries than you would, say, with other, I don't know, like fruit trees or other things like that?
Yes, actually, grafting blueberries is very particular. We kind of developed a new method. There's a video coming out where we teach about how to graft a blueberry. But basically, that ended up not being part of my project. Finding out how to graft a blueberry took lots of trial and error, took grafting 100 plants and having 5 surviving. Until now, we are coming to around 80-90% graft take. That is the survival of the tree. So now we have another student, Valentina. She's looking exactly into that, into how to develop techniques, when is the best timing to graft, what is the best method, if there is any better method than what has been working for us. So grafting blueberries has been a big challenge on this research because they don't really like to be grafted.
So they are difficult. So what are some of the difficulties? So you talked about you're trying to graft 100, maybe 5 only take different times and places. If you want to get into some of the difficulties or challenges that you have with that, and also what are some of the different rootstocks that you mentioned sparkleberry. Were there other rootstocks that have been experimented with, and how did things kind of coalesce around sparkleberry as a potential rootstock?
So the only rootstock we've been using is sparkleberry. It's the only plant we've been using. But this plant has been selected. So inside the population of sparkleberry plants, my professor, Dr. Williamson, for a long time already has been selected the sparkleberry plants. So he basically observes these plants. So yeah, for sparkleberries, they are not crossings, they are wild plants. So all we have been doing is selecting which one grows better or which ones have a better take. So now I believe we have 5 or 6 selections that we like, that are giving us good results. There's a lot of work to be done with them to test and see. I mean, this whole project, there's a lot to be done before we take it to commercial production.
With the idea of grafting for resilience purposes, what are some of the specific characteristics that you're looking for within the blueberry plants to allow them to be more resilient to a variety of climates and environments?
What we're looking for in these rootstocks is basically a plant that's going to grow a big root system, better than a blueberry. We need a root system that grows to deeper soil layers, so we can access not just water that is stored down deeper in the soil, but also nutrients. So this grafted blueberry project englobes on my PhD 3 different projects. The first one, we were looking into how we could grow these plants. The first experiment, we focused on looking on yields and fruit quality of unrooted blueberries and 3 different rootstocks. This work is published already, and these plants were grown in a field with less amendments that are normally used for growers in Florida. So as the roots of blueberries are very, very sensitive, very shallow again, they need constant irrigation, and they need a lot of organic matter. Blueberries are also very particular about the pH, so they prefer an acidic pH. So all of these are inputs that go into blueberry production. With our first experiment, we found out that grafting not only improved the yield, actually the plants that were not grafted were producing half the amount of fruit than the grafted plants in these conditions. So we could see in this first experiment already that there was something different, that these plants were already doing better than the normal unrooted blueberries. After this experiment, we ran a water deficit experiment. So the second experiment, we focused on looking at the same plants. Actually, we were looking only at one rootstock, but we were seeing how differently these plants behave or respond, how differently these plants respond to water deficit stress. In the second experiment, we basically attached the meter soil water potential sensors to the roots, by the roots of the plants. We attached the psychrometer to measure stem water potential, and we were measuring also gas exchange during this period of drought. These results are really nice to see. What happened is that these roots, these grafted plants, they didn't feel the drought. They didn't notice that they spent 10 days without getting water. While the blueberry plants, during these 10 days, they started decaying and eventually they were about to die. On the last day of drought, they were dropping leaves. It was the day that we said, if we want to keep these plants here, if we want to keep these plants here, we need to stop the experiment. Otherwise, we're gonna kill the blueberry plants, and when we're only gonna have the grafted plants standing. Then the third experiment is still a project. We haven't decided much about it, but to englobe soil amendments, water, and fertilizer, the last experiment is going to be about nitrogen. In this nitrogen experiment, we want to compare and see how different. In the nitrogen experiment, we want to compare the unrooted plants to the grafted plants to see if maybe this plant can absorb a different form of nitrogen, or maybe more nitrogen, or maybe, I don't know. We're still deciding on how this research is gonna be, but that's our goal.
As you were talking about your different experiments, what are some of the amendments that are used with growing blueberries, or traditionally used with growing blueberries?
In Florida, the most used is pine bark. Is either added on top of the soil, so on top of the sandy soil to make beds, or incorporated to the sand to add the organic matter to the soil and make a mix.
What are some of the specific measurements? I guess, in talking about kind of the techniques and technologies, what are some of the specific measurements? You did talk about water potential and gas exchange. You talked about using a psychrometer. What were some of those, I guess the outputs that you were looking for? How are you measuring the resilience of the plant through the sensors and the measurements that you were taking?
The way we were measuring the resilience was by how the plants were responding to the drought. So every day we were there looking at the plants and reading the sensors. We didn't want to go too far, so we were looking into how wet the soil was with the soil water potential sensors, how this water was being pulled by the plant with the psychrometers, and how much water was leaving the plant with the gas exchange measurements. So we had photosynthesis, we had tomato conductance, and we also collected some leaf samples to later on, we want to look into osmolyte accumulation. So if these plants have different osmoprotectants in response to drought.
What have been some of the key findings so far? And you said there's some preliminary data and findings. You're still working through some of these experiments as well. What are some of your preliminary findings or insights that you've gained from your work so far?
The ability of a grafted plant to withstand drought is incredible. I think that's the highlight of this research. So two plants very similar, where the only difference between them is the root system. And to see one of them dying and the other one not even realizing that has been without water for 10 days. I think that was the best result. I think that's very rewarding.
Were there any major challenges or roadblocks that you had to deal with these experiments?
Okay, that's a great question. Because working in the water deficit experiment, we actually had to run this experiment 3 times. The first time we ran the experiment in a greenhouse, and the results were good, but they didn't represent what these plants are in the real field, in the real conditions. Because of size pot, because of the limitation of the roots, so we decided to run the water experiment in the field. So for my first time doing the field experiment, the field water deficit stress, we planned for it in a week that was supposed to not rain. I had a structure to prevent any water to get into the plants in case of any rain happen. But in the fifth day of drought, something happened. Hurricane came, big rain, really fast winds, and my structure didn't survive. So my drought experiment was washed away. That was very, very hard, very disappointing, very frustrating. We ended up getting some relatively good data out of this experiment, but we knew we could do better. So we ended up deciding to run this experiment again, a third time in the field. We improved our rain shelter. We made some changes. We made more accurate experiments, which ended up being good, and it worked out this time. So I guess this challenge of working with plants outside of not having any control of, yeah, is it gonna rain? Is it not? I'm in Florida, so it's even more difficult to predict. That was definitely one thing that shaped my PhD. It was a very difficult challenge that I had to overcome.
I can imagine, especially working there in Florida. You do have hurricane season that lasts for several months, and trying to do any kind of long-term research projects are can be difficult. You did mention about setting up experiments and then having to change things up because you felt like that the previous experiment did not represent what might be seen in the real world. You've also done experiments in both in the soil in a natural environment as well as in soilless media and soilless substrates. Can you tell us a little bit about the difference of working with blueberries in, I guess, what you see that might be different in working with them in greenhouses and soilless media? And what are the differences, or what do you see when it comes to growing and cultivating blueberries in soil versus soilless media?
When we ran this experiment in the greenhouse, we didn't use substrate. What we did was try to replicate how the blueberry system is in Florida. So we had these 75 centimeter tall containers, which half of the container, the bottom part of the container was filled with sand, and the top part of the container with pine bark. So these plants had the environment that they would have in the field. The limitation ended up being on the diameter of the pots. The plants grew too fast, very fast in the greenhouse, and we weren't ready to run the experiment when they were on the right size. It's not that we don't trust those results, they were great, but we needed to see how these plants were gonna do in the real scenario.
You've done some other work working with like cocoa coir and some other soilless media. That's where I was what I was trying to get at was what were some of the experiments that you've done in cocoa coir or other soilless media, and what were you looking for? Why were you using soilless media versus soil? Was it indoor, outdoor? Can you give us a little insight into some of those experiments and what were you looking for and what you found when it came to working with cocoa coir and other soilless media?
Before I started my PhD, on the year before I started working with grafted plants, I ran a few greenhouse experiments with soilless media. So we used coconut coir and rhizoboxes. So we were working with very young plants. What I studied at the time was coconut coir is very saline, so it has a lot of salt. And blueberries don't, and not a lot of plants like salinity on the substrate. Our experiment was washing out this substrate before planting the blueberries. It had nothing to do with grafted plants at that time. We found out that washing that coconut coir with a deionized water to remove the salts and then adding fertilizer we added calcium nitrate. So this calcium nitrate was replacing the salt from the substrate with nutrients. Basically, what we found was that adding this calcium nitrate was promoting more substrate respiration. So it was making the soil more active. There were more microorganisms alive on that soil.
So that was before your PhD. Got it. Okay, that makes sense then. Have you taken any of those insights that you gained from that and applied it to any of these experiments that you're doing for your PhD work?
Not yet. I don't think we will, because the focus of the grafting a blueberry is to improve the root system. And I believe that substrate production, the roots are not suffering on that environment in any ways. So they are very pampered, they are treated very well. So plants, blueberries grown in cocoa coir substrate production, they produce much faster. They produce in one blueberry plant with 1 year is producing fruit already. 2 years after being planted is giving high yields. So I think that's the benefit of using the substrate, but not exactly for grafting.
With some of your findings so far, and maybe this is kind of getting a little bit ahead because you're not fully, you haven't fully completed these final experiments. But I was just wondering about some of the applications of some of the findings that you've seen so far. How do you anticipate that this research or might be able to impact blueberry production when we're dealing with having sparkleberry rootstocks, or the grafting process, or less need for soil amendments, or I guess when it comes to like irrigation management, other things like that? Can you kind of give us a little insight into how you feel or hope some of your findings might be applied to blueberry production on the commercial side of things?
I think our main benefit from having grafted blueberries is the cost effectiveness. I hope that with grafting, we can reduce the cost of production and establishment for growers. The cost of pine bark accounts for almost 1/4 of the entire establishment of a blueberry field. So we hope to reduce costs, maybe also reducing irrigation. If these plants can be grown with less water, that would be amazing, as we saw on the drought experiment. We want to grow these blueberries with less input, but we don't want to miss on yield or fruit quality. So grafting has been proving to be great for that reason. It hasn't affected any of the fruit quality and yet increased the yield. Another way of reducing costs is going to be the machine harvestability of this crop, not just the reduced berry loss, but also the cost of harvesting. Manual harvest is also very, very expensive for growers. And of course, we hope these plants to be more resilient and capable of withstanding the impacts of climate change.
With all this work, and eventually your hope is that this will be applied into commercial growing of blueberries, correct?
Yes.
So with that, are you collaborating with any commercial growers, or are you working with extension programs that then connect to growers when we're dealing with blueberry production there in Florida or elsewhere?
Yes. So in the end of these 3 experiments, we are going to have 2 commercial farms with grafted blueberries, one in Florida and one in Georgia. And they're going to be testing basically our findings. We're going to have the plants with less pine bark. We're going to have maybe the plants with less water. We haven't decided that yet. And same with nitrogen. So this has never been tested in any commercial settings, but this is our goal by the end of these 3 experiments.
So along with the collaboration efforts, how have any other, educational or outreach efforts gone? Have you been in direct communication with growers or with other, researchers or breeders? Are you sharing your findings with the broader agricultural community? And how do you feel that process will go going forward?
Yeah, actually, it's very interesting because I don't only go to conferences, to academic symposiums and stuff, but we also go to field days and we host field days. So at least once a year, we are in contact with growers, and it's very nice seeing how they are interested in our research. Having these moments is what guide us to our research. We are here to help the growers, and we are trying to find better ways for them to work on their blueberries.
What do you see in the next, I don't know, like 5 to 10 years? What do you think could be accomplished when it comes to research within blueberry production and improving resilience of blueberry varieties?
I think grafted blueberries are a very promising alternative for climate change. I believe these grafted plants are more resilient, more sustainable in different ways. There's a lot of work to be done for grafted blueberries to be commercially available for the growers. There's a lot of questions regarding the rootstock. We know that sparkleberry has single trunk and all of these traits that we are looking for, but there might be different plants or, again, the selections to be used. I see more people being able to produce blueberries. I believe that if this system is a low cost production system, it can also increase the number of people who can go grow blueberries.
When you were talking about using sensors, you talked about water potential, you talked about working with psychrometers, you talked about gas exchange sensors. Were there any of those that you felt the measurements were better correlated to the final, quality of the fruit or the production, the yield, or other things like that? So were there changes in water potential or other things like that you saw that then directly influenced or were correlated with final output or final quality of the blueberries?
So one of my favorite sensors to use or technologies to use were the psychrometers. At first, they were very challenging for me to understand and to install, and they take a lot of time. But the data that we got out of it was very clear. We got the daily curves of changes in stem water potential very well defined. So I think that's my favorite piece of research. But all of these sensors were extremely important to make it possible for us to look at this system as a whole. I think only psychrometers would not have told us the story that everything together did.
What are some of the things that you have learned through your work within blueberry studies that you feel you could take, or within your PhD studies in general, that you could take with you beyond your doctoral work and when you move beyond?
Resilience. I think just like grafted blueberries, doing a PhD takes a lot of resilience. So I love this connection because it's what I'm looking for in these blueberry plants, but it's also what I'm looking for in life. It's being able to adapt to different environments.
That's beautiful. Are there any other final thoughts or things that you'd like to share that we didn't get to cover today that you'd like our audience to know about?
Yes, actually, the fellowship that I got from Mater in 2022, that shaped my research, the water deficit experiment. And I want to tell everyone that is listening to please apply if you are a student. It was $10,000 in research equipment that was very well used for, as I said before, soil water potential.
All right. Well, our time is up for today. Thank you again, Cecilia. We really appreciate you taking time to talk with us. It's been a very interesting conversation into blueberry horticulture. So thank you.
Thank you. Thank you for having me.
And if you in the audience have any questions about this topic or want to hear more, feel free to contact us at metergroup.com or reach out to us on Twitter at meter_ENV. And you can also view the full transcript from today in the podcast description. That's all for now. Stay safe, and we'll catch you next time on We Measure the World.